Okay, so these properties of equality over here, like an example of where you've seen this is, okay, you have an expression like x plus 7 equals 15, and then to solve this, you subtract 7 from both sides, and here you would be using the subtraction property of equality. So essentially in this lesson, we're solving equations and we're just naming the property we're using to solve it. And that's what you wrote down here. So here you're saying that you can add the same value to both sides, it's still equal. You can subtract c from both sides, it's still equal. You can multiply both sides by the same number, still equal, or divide both sides by the same number and it's still equal. And that's the basis of like how we solve equations. Then down here, this property, distributive property, you've seen this quite a bit since elementary school. To use distributive property, you take the value on the outside of the parentheses and multiply it by both values inside. So you'd get AB plus AC, and that's how you use distributive property. Substitution property, we use a lot as well, especially in algebra. If A equals B, then A may be replaced by B in any expression or equation. So where you see this is like, okay, let's say you have an expression like 2x plus 1, and then you're told, okay, x equals 7. You would take this 7 and substitute it for x. That is called substitution. And it would look like 2 times 7 plus 1. Okay, and then reflexive property might be new. Reflexive property is just A equals A. It seems kind of silly at this point that we have to explain that, but it does come up in some of our lessons, and it'll make more sense as why we're explaining that now, like later. Lucas? Okay, symmetric property, it might be new as well. Symmetric property is A equals B, then B equals A. If you know anything about symmetry, like symmetry is like a mirror reflection on both sides. Like if you had a heart, it'd be like symmetrical on both sides. So that's a way that you can remember the symmetric property. It just like, it's like a mirror image on both sides. Okay, transitive is new. Transitive is like the most popular award, kind of like Cooper. Just kidding. Transitive comes up a lot. So transitive is A equals B, B equals C, so A equals C. Does that make logical sense to you? Does that make sense? If A equals B and B equals C, then A must equal C. I'll give you more of a visual example, actually. Okay, so let's say Peyton is the same height as Edwin, and I'm telling you Peyton's the same height as Edwin. And then Edwin is the same height as Jose. Then we could say that Peyton is the same height as Jose. So that's transitive. So since Peyton's the same height as Edwin, and then Edwin's the same height as Jose, then Peyton and Jose are the same height. And that's transitive. And that's what it means here. If A equals B and B equals C, then A must equal C. Okay, then down here, we're not gonna do all of these examples because they're kind of structured, kind of weird, but we're gonna do number 1 and we're gonna do number 9 down here. Okay, so number 1, it says given 6x plus 2 equals 12, and the conclusion is that 6x equals 10. So we're looking at how they got from this step to this step in terms of like solving equations, and they subtracted 2 from both sides. So therefore, to get from this step to this step, they use subtraction property of equality, if you want to be technical. And then, like I said, we're not going to go through each of these examples. There's plenty more examples on the next page. But number 9, it says 4n plus 6 minus 2n equals 9. They combine the like terms to get 2n plus 6. So 4n minus 2n is 2n here. So the reason here would be combine like terms. But sometimes in problems, I see it differently. So that's why I wanted to really outline it. Sometimes they say, they call this substitution. Sometimes they call this substitution. So just be aware that if combined like terms isn't in like the answer choices, you can use substitution. Okay, and then once you're done with that, flip to the next page. Okay, so on this page, it says name that property. They're going to give you a bunch of different situations, and you have to name the property that they're showing. All the properties here are the same ones that we saw in this chart, so we'll be referencing this a little bit. Also, I know that there's letters next to these, but I want you to write out the property because it'll help you learn it and remember it as we're doing this. So for the first one, it says if k equals 3, then 3 equals k. That one is the symmetric property. If a equals b, then b equals a. So we're going to write symmetric property. Okay. Then number 2, 2x equals 14, then x equals 7. How did they get from this to this? Well, they divided both sides by 2. So they used division property. Then we have 4 equals 4. If we look back at our chart, a equals a was reflexive property, so 4 equals 4 is reflexive property. And the next one, to go from this to this, they added 1 to both sides, so that would be addition property. Then number 5, 10a equals 2b and 2b equals c, then 10a must equal c. So this is transitive property. If 10a equals 2b and 2b equals c, then 10a must equal c. Number 6 should be recognizable. Multiply that negative 7 by both terms to get this. That is distributive property. The next one, they show minus 3 on both sides. So that would be subtraction property. Number 8, it shows an equation. Then it says w equals 1, and then they plug in 1 for w. So they're taking 1 and plugging it in for w to get this. That is substitution. Number 9, to go from here to y equals negative 20, they're multiplying both sides by 2. So that is multiplication property. Number 10, 3x equals 2y and 2y equals z, then 3x must equal z. That is transitive property. The next one, they're adding 4 to both sides, so that's addition property. This one, negative 2x equals 18, then 18 equals negative 2x. That is symmetric property. For the next one, they give you an expression and they say x equals 5, and then they plug that in for x to get this expression. That is substitution. Number 14, to go from this to this, they multiply both sides by 8. So multiplication property. And for 15, 10y equals itself. That is reflexive property. Like I said, it'll make sense more in later lessons why there's this. And then 16, they like factor out the x, also known as distributive property. Okay, and then we're going to move over to the next side. Well, not like, don't flip the page, we're just moving over to the right side of the page. Okay, so some of the questions on your homework will look like this, where you're just naming the property. And now we're going to introduce proofs. Of course, this is also in the homework, but this is the introduction to proofs. Have you guys seen tables like this before? Yeah, some of you, yes. I've gotten a lot of no's too, so if your teacher didn't show you, that's cool too. I'm just going to teach it from scratch anyway. So these are called two-column proofs. There's two columns. On the left side is like the steps, which are also called statements. And then on the right side are the reasons or justifications for each step. They're called reasons. And what can you use for the reasons? You can use postulates, theorems. You can use properties and definitions. For today, we're just going to be using the properties that we learned, so we're kind of sticking with that, but eventually we'll work in these other things. And so for these, you'll see like it's pretty dry, like it's just algebra, but toward the end of the week, provided we don't have hurricane days, maybe next week, I guess we'll see. For the end of the week, they bring in the geometry stuff with it. For example, on these, you'll see like geometry shapes and stuff like that. So we're building the structure using algebra that we're going to use with geometry. So the first thing with a proof is they always give you a given statement, and this is where you're starting. So you'll always see the given filled in the first line. So this right here is the first line, and it just says given. And we're working toward the proof statement, x equals 7. They listed out the steps for us, which is nice, and then we just have to put the justification over here of what they did. So from 1 to 2 here, to go from this step to this step, they added 1 to both sides, so that was addition property. So the way they got this answer was they used addition property. Then, to go from 2 to 3, they divided by 4, so they used division property. Okay, number 2, same process. The given always goes in that first line. They wrote the given and they put given as the reason. And then we're going to look at how they solved it here. It looks like the first step they did was they subtracted 2 from both sides. So they used subtraction property. Then from 2 to 3, they multiply both sides by -6 to get a by itself. So they used multiplication property. Okay, then the next one. Again, the given goes right in the first line. Just fill that in right away if they don't fill it in for you. And then to go from step 1 to 2, they distributive. Yeah, I heard somebody say it. Good job. Distributive property. To get this step. And then to get the next step, subtracting 27 from both sides. So that's subtraction property. Then to go from 3 to 4, they're dividing by negative 18. So that's division property. Then number 4, if it's emergency, you can go. Okay. Number 4, given in the prove statement here. So given goes in first. Prove is what you're working towards. So that's going to be at the bottom. And then we'll just look at each step. To go from here to here, subtract 6x. So that would be subtraction property. Then the next step, I would add 17 to both sides. So that would be addition property. Then from 3 to 4, dividing both by 2, division property. And then they just switch the order. They had 12 equals x, they switched it to x equals 12. The reason why you can do that is because of symmetric property. And when you get that done, we're flipping to the next page. Just flip it when you're ready. Okay. So on this page, we put it all together. Notice how our charts are literally blank, and we have to do it all on our own. So the first thing that you always do is take this given statement and plug it in the first line. So I'm going to plug in 3x plus 1 equals negative 14, and I'm going to write given. Prove is what we're working for. That is going to be the last line. I'm going to wait to plug it in because sometimes I don't use all these lines, just FYI. Okay, so first step in solving this would be subtract 1 from both sides. So I'd get 3x equals negative 15. And so the reason is subtraction property. Then from here, divide both sides by 3. Get x equals negative 5, and that would be division property. And that's all. Once you get to the proof statement, which is x equals negative 5, that's what I got. We're done. Okay, the next one, the given, first things first, plug that into your first line. Like if this was partial credit for everything you filled in right, make sure that you're getting that given right because it's the easiest one to get right. Okay. Then from here, I would use distributive property to get 2x minus 18 equals negative 10. Reason, distributive property. Then from here, add 18 to both sides. I get 2x equals 8. So that is addition property. And then the last step here, divide both sides by 2. X equals 4, and I use division property. Okay. Number 3, going through the same steps, just start with the given, and then write this in the box. Then to start solving this, I'm going to subtract 10 from both sides. I get m over negative 3 equals negative 11, and I use subtraction property. The next step to solve this and get m by itself is to multiply both sides by negative 3, and I get m equals 33, and I used multiplication property. And then once I get to the proof statement, which is m equals 33, I'm done. Okay. Last one here, same process. Start out with the given and plug that in here. 5y minus 1 over 2 equals 7. The first step I'm going to do to solve this is multiply both sides by 2. So I get 5y minus 1 equals 14. And I used multiplication property. Plus 1 plus 1. 5y equals 15. Addition property. Last step, divide both sides by 5. Y equals 3. And I use division property. Okay, and then I have one more note of something that you'll probably need to know for the homework. So just write this down on the bottom of your page in case you get a question that asks about this. If segment PS is congruent to segment WX, then PS is the same length as WX. PS is the same length as WX. The reason that we can say this is because of definition of congruent segments. Definition of congruent segments. If they're congruent, then they are the same length. Okay, so your to-do list from now until the end of class, you have homework 3-4B on Schoology. Some of you got distracted with the video yesterday and didn't do yesterday's homework. So if you need to do yesterday's homework, use today to get that done if needed. And then also work on your Alex. And remember, even if there's hurricane days, Alex is still due at the end of the week. So make sure that that's done so hurricane doesn't mess with your grade.